Hello everyone, this is Anu here. Welcome to my YouTube channel. Today we are going to discuss about a sorry, new topic that is regarding the Docker Compose. In my previous video, we have seen how we can spin a single container application using Docker file. Now we are going to see how can we leverage Docker Compose to spin multi-container application. If you see my screen, this is a multi-container application which is having backend, database, frontend, and Nginx. And if you see the inside of this application, for every components, I have a separate Docker file. Okay, for backend, this application, and this is a Docker file for backend. What it is doing, it is downloading a lightweight Python 3.12 Slim package. It is downloading to build this application, setting /app as the working directory, and it is copying the requirement.txt file and installing the requirement file, then exposing the port 5000 and running using UV code because we are using fast API. And in the DB, if you see, this is the Docker file. It is downloading the Postgres 16 Alpine, and it is initializing using this one. This init.sql file, it is having the SQL script to run. If you see this one, it is asking to create a table. In the front end Docker file, you can see we are using Node.js. It is downloading the Node.js 20 Alpine, that is the lightweight image. On top of that, it is doing the following commands. First is a two-stage. First, it will build this application using copy this one and npm install and npm run build. It will create the lightweight static file. That static file will be fed to the Nginx server. And Nginx server will copy that HTML file into Nginx HTML and export the service to the port 80. And finally, it will running this command. And when come to Nginx, this is the Docker file for Nginx. What it is doing, it is downloading the Nginx Alpine package, that is the image, base image. On top of that, it is running this following command, copying this nginx.conf and exposing to port 80. What this Nginx is working as a reverse proxy. What are the requests coming into this Nginx? It will be routing appropriately whether to go to the front end or to the back end. How it is doing, we are configuring this using the nginx.conf file. Sometimes it will be default.conf file. That depends upon how we are renaming this file. If you see the nginx conf, here we have this two configuration, upstream front end and upstream backend. This is inside the container, how it has to be routed. If it is front end related request, then it will go to the port 80 and it will go to the front end container. If it is a backend related or API related, then it will route it back to the API related to that container. And if you see, I have given the port, that is host port, as 80. If any request which is coming into /API, then it will request will go to the API server or the backend server and it will serve the request. If it is something related to just other than the API, is just forward slash or something, or to the any other request apart from the API, then it will route it back to the front end. This is how it is doing. This is how Nginx is routing all the requests from outside world to the inside container and doing the network. This is all about the internal architecture of this Docker file. And let's go ahead and see what is the Docker Compose configuration. In the Docker Compose configuration, we can see for every services, there is a separate container configuration. So for DB, there is a configuration. And for Python, there is a fast API, there is a container. And for the front end, there is a container, and then finally Nginx, and next come the networking and volume. Let's see why this order matters. DB always need to be run first because the backend fast API require the DB connectivity. Only after this two is running, then only the front end will come up and serve all the requests. So next come this front end. After that, the Nginx reverse proxy will come into picture. This will act as a reverse proxy to serve the requests. What are the incoming requests coming into the system that will be served to the outside world. Then comes to the network. Networking, we are using default bridge network inside the Docker container, and we are using persistent volume. I'm going to cover the volume related configuration also here. That is called the Docker volume. Why we are using volume? Because if the container is stopped or then container is down, if there is no volume, what are the data we have shared will be lost. Instead of that, we are using Docker volume to save the data persistently. Let's go ahead and spin this application and see how it is running. To run this, let's close this compose. Run this application. I'll be opening a new bash terminal. Currently, there is one image is there that is related to some other application. Let's delete this and not required. Let it be there. No problem. Container. Yeah, this is also related to some other application which is running. Let's get this. To run this application, we can use docker compose up build. Or if you want to run it in a detached mode, then we can give -d command. Okay, docker compose up -build -d. It will run in detached mode. Okay, and to bring down that particular services, then we can use docker compose down. Let's bring the service up. We can use this detached mode. Let's copy this one. Okay, let's run this application from the root directory. Let's see. Now it is downloading the images. It may take some time to download all the images. They depend upon the size of the image and network bandwidth you have. If you go ahead and see the images session in Docker Desktop, see it starts downloading the images. Task Tracker App Frontend and Nginx. Frontend is Node.js and Nginx is a Nginx services lightweight application. It's only 92 MBs. And it is going to download the next. Yeah, that also got downloaded. That is DB is a Postgres vector that is also downloaded. Let's wait for a couple of minutes. Yeah, it started creating. Now already downloaded. Now it start creating the container. Let's go ahead and see the container. See, test tracker. This is our application. Test tracker application has been created. Now let's start this. See, it has started the application. Let's create task 1. Add the task. If you want, you can add description, pending, and create new task. Task 2, add task, task 3, and task. Okay, these are the tasks I have added. It's just a task tracker kind of application or to-do list kind of application. And let's try to see a few commands. Let's open the terminal here itself. Yeah, let's see. Docker PS. You can see all the running commands here, running containers here. This is PG vector, task tracker app frontend, task tracker app DB, task tracker backend. You can see all the 4 containers are running together. Docker images, you can see it has downloaded these images. Okay, let's go ahead and see let's try to stop this Docker container and see how it is behaving. We can stop it from this Docker desktop, otherwise we can use the command line to stop. Command line, if you see, you can use docker compose down. Ready to select this, just copy this one. Just go docker compose down. It will bring down all services. Then it's not only remove, it will stop, it will remove the content also. But the images will be available. Next time when we execute this command, only the first time we need to execute the command build. Next time we don't need to execute the command build, right away we can just give docker compose up. It will immediately start creating the container because the images are already there. Those images are already compiled to one using our commands. Command means what are the configuration we have given in the application. Those all combined together, and those images are already available. From that image, it will spin up the container. So these are the build. Let it be there. See, containers are done. Yes, we can stop it from here also. Let's stop the service and see whether we are able to access the application now. No, it's not accessible now. I'll be starting it once again. From here, we can start now. It'll take some time to bring this applications up. Yeah. And let's see. See, this data is persisting even though we bring the services down. That's why, because the data is persisting in the backend volume. Backend volume in the sense, if you go to this Docker desktop and volume, if you see, this is the task tracker application. This is a persistent volume. This is a Postgres database is storing inside this file. If you see this PG, this is related to the Postgres. We are saying all the database in the backend Postgres. These are all data or table related files and folders. This is what this Docker container volume or Docker volume. That's the importance of the Docker volume. Next thing, we can go ahead and see the architecture diagrams and all, and I'll explain to you what is this overall architecture of this application. This is the task stack wrap architecture. This condenses a three-tier web application composed of React SPA, Fast. This is not the Flask; it's a Fast API, REST API, and Nginx. And system diagram, if you see in the browser, use a command hit the browser. It will go to the Nginx reverse proxy. Reverse proxy means what are the request which is coming. We will be exposing through this Nginx reverse proxy. Reverse proxy will expose to 80. Here the port I have used is 80. Sometimes that will be 8080 or some other port. That means if I'm using 8080 port, then it will be localhost colon 8080. Then we can access the port. Internally, the Nginx will be using the port 80 to route this application. How it is routing this application? If it is something related to API request, then it will go to the API backend. If it is something related to the front end, then it will go to the front end. Apart from API, all the requests will route it back to the front end. If you see this Nginx reverse proxy, /* all requests go to the port 80 that is related to the React front end. All the requests which is related to API, then it will go to the port 5000 and it will go to the Flask, either it is a Flask or Fast API, depend upon the API service we are using, it will go to that one. Then Psycho PG2, it will convert that request into the Postgres request and it will go to the Postgres database to serve the request. Next comes, we'll go ahead and see the internal architecture of Docker, Docker network, and Docker volume. If you see the Docker network, let's expand this one and see. This is already I have explained just before. This is browser. User is hitting the browser, then go to the host machine through port 80. It is mapped to the Nginx using the port mapping. As of now, I am using the same port 8080 for internal and external of this Docker container. Here, this bridge network. Internally, Docker is using the bridge network. That is the routine net. That is the name I have given. If you see this Docker compose file, it will be clear. Docker compose. If you see this network, this is the name of the network I have given. That's why it is showing us that name here. We can change the name. Then it will depend upon the request type. It will forward to the front end or to the back end. If it is API related, then it will go to the port 5000 and go route it back to the backend services. And from the backend services, it will go to the database services, PsychoPG connection. PsychoPG service will route this request back to the PostgreSQL. If you see this diagram, we can see all the services. This host machine is a separate entity. browser is a separate entity, host machine is a separate entity. If you see this networking is inside this yellow box, and the Postgres data is outside. This is why, because this database, this is a persistent volume which is residing in our machine. Okay, that's it is not related to the container, so that's why it is outside this yellow box. Okay, then come to a bridge network. This is how the network is going on. All the requests will come to Nginx. There are DNS for front end, DNS for back end, DNS for database. Front end related requests will go to the front end DNS, back end related requests go to the back end DNS, through which it will go to the DB DNS, and the request will go back. Let's go back and see the port strategy. Port strategy already I have explained in the previous diagrams. If it is port 80, that is the port we are using to access this application through WebUI, then it will to the port map, that is, sorry, port 80. It will go inside this routine net, that is network interface name for this complete container. It will go to the Nginx. Depend upon what kind of request it is, it will go to the port 80 or port 5000. If it is port 80, that will go to the front end. If it is 5000, that is go to the back end. How it is identified, whether it is slash API, it will go all to the API request, that is the back end. If it is something else other than the slash API, then it will go to the front end. And then it will be access the database using 543 port, 32 port. Okay, this is the Nginx reverse proxy traffic router. Let's discuss about this one. Okay, we will get this request to the browser. There is a get request. It will go to the Nginx 80, and depend upon the request, it will go to the front end. That is proxy plus HTTP. It will go to the front end. Then it will get the HTML, JavaScript, and CSS, and it will go back to the browser. Once we get the browser access, then we'll request either API or task. Depend upon the API, it will route it back to the required services. From this Nginx, now it will pass to the backend, and backend will check which kind of service it is, whether it is a health service or any add service or remove service or delete service. Depend upon that, it will take the action and return a JSON back to the Nginx, and from the Nginx, it will give the response back to the browser. This is how this data flow. This is the backend database connectivity. If you see the backend runtime, resolve the database using, and it will give the IP address back. Using that IP address, it will go to the Docker. Initially, it will go to the Docker DNS. From the Docker DNS, we'll get the IP address, resolve the IP address, and get the TCP connectivity to Psycho PG, and it will go to the DB runtime using 5432 port. And once the connection is established, then we can execute the SQL queries and return the results. The service startup process, initially the database should be up and running. That depend, because backend is dependent upon the database. Once the database is up, then backend will start up, then the front end will start up, because the Nginx depend upon both backend and front end and database. Once all the three is up and running, then Nginx will start running, and it will start working as a reverse proxy. And this is the persistent volume. Persistent volume, as I said earlier, we use this persistent volume to save the data irrespective of the service go down or bring anything happens to the container. The data will be persistently stored inside our local machine or to the init server. And this is where this DB container, and it will be storing it in outside the container world. Okay, this is the complete request lifecycle. Through the browser, there is HTTP request is coming through the port 80. It will be forward through the port mapping to the Nginx inside the N routine net, that is the internal bridge network. Then that proxy pass to the location, whether to the front end. Initially, it will pass to the front end. From there, it will get all the HTML page, JavaScript bundles, and all. Then it will go to the user. The user will get to know the web UI field, and from there he can go ahead and click over any activity, add new services or add new tasks. We have already seen add new services or delete new services, add new command. Then fetch API task, it will fetching all the tasks, then forward through port mapping through this bridge network. It will go to the backend network, and then it will do the required services. That means adding any task, adding any comments, or deleting any task, setting priorities and all, and make the changes in the rows. That is, this stage it is connecting to the backend database to do all the CRUD, that is create, delete, update. Those kind of activities will be done on the PostgreSQL and come back, and it will return the rows as a JSON array, and it will give this response back to the user through the web UI. This is all the complete request lifecycle of this application. And this is all about this Docker Compose and Docker Volume, how we can use the Docker Compose to spin up a multi-container application, and how we can use the Docker Volume to store the data persistently in any Docker system. Thanks for watching this video. That's all about this video. We'll see you in the next video. Thanks. Bye.